Hello everyone, and nice to meet you. My name is ATM Math. Today we're going to learn about the second type rules for evaluating derivatives, and we're going to learn about the quotient rule and the chain rules. So let's get into it. The quotient and the chain rules of derivative, we're going to learn about this. And the derivative represents the instantaneous rate of change of a function. You probably have known it. If you haven't learned it, see my other bits and my previous bits. And we can just present it as limit h goes to 0 and h under fx plus h minus fx. So, okay, it can be super tedious to use this formula every single time, which is why we use the quotient rule and the chain rule. Quotient rule is a method of finding the derivative of a function that is a ratio of the different function to differentiable functions. Here's a visual representative of the function rule, quotient rule. If hx equals gx under fx, h prime x equals, oh my god, I can see it in yellow. So h prime x equals gx squared under f prime x gx minus fx g prime x. Got it? So now I'm going to prove the quotient rule, and I'm going to let hx equals gx under fx. And now let's prove it. Since it is this, fx equals gx hx, right? Alright? Then by the product rule, we can get f prime x equals g prime x hx plus gx h prime x. Then nextly, solving for h prime x and substituting back for hx gives h prime x being gx under f prime x minus g prime x hx. And since hx equals gx under fx times gx to both the upper town in the place and the downer town in the place, we will both multiply gx squared f prime x gx minus g prime x fx. What were we going to prove? H prime x equals gx squared f prime x gx minus gx fx g prime x. So this is a very easy proof, and if you want to prove it, you can use the proof of using reciprocal rule and the chain rule. But since we did not learn about the chain rule, we're not going to talk about that. And also, if you want to talk about something, you can also prove it by using the derivative definition and the limit properties, but it took about probably 5 minutes. So let's just go on. The chain rule is that if hx equals fgx, then h prime x equals f prime gx times g prime x. So the chain rule was first used by Gottfried Wilhelm Leibniz, and he used to calculate the derivative of a plus bz plus zz squared as the composite of the square root function and the function a plus bz plus cz squared. He first mentioned it in 1676 Memoir with a sign of an error in the calculation. But with the chain rule, we can get something crazy and absurd. It is called the Fadi-Bruno's formula. Where is it? Where's my mouse? Okay. Fadi-Bruno's formula. And it was made by Francesco. Am I right? Okay. Francesco Fadi-Bruno. Francesco. I'm not sure about the spelling. Probably this is a C, since he is Italian. Okay. He has made this a lot of things. The first one is easy, since dx under dy is quickly disappear and it becomes dx under dy. And this are all expandation, and expand. But we cannot expand here because the fifth and the sixth is not expandable. Why? I'm not sure. I don't know why. It was proved by Everest Galua and Nick Hans Bell. I'm not sure about his name. Galua and Bell proved it. They both died early because of a girl of love. Anyways, what I want to tell you is that you need to expand your thoughts. Expand, and expand. Then you can get something. And if you cannot expand, then you've done your work. So please, expand your thoughts. Then your brain might be bigger and bigger. Your brain started as this much, then this much, then this much. And you will be smarter and smarter using my classes and lectures. Thanks for watching my YouTube at www.youtube.com/AdenTeachesMath. And it is also available for my secondary account, Aden Teaches Math 2. And my history is adenteachesmath.history.com. But what you need to make sure is that there is only https // no www. And for my mail, it is adenteachesmath@gmail.com. Or for my Korean users, adenteachesmath@naver.com. Thank you for watching my lecture, and bye next time. Let's learn about something more about the derivative. Thank you for watching.